Today in class, we did pages 10 and 11 in our notes packet, and today I'm on page 12, and we're going to talk about some of the things that happened during the activity with the colored pencils. What we did was we used some transformations, such as a line reflection, translation, which I call a shift, because it just moves something left, right, or up or down, and dilations, which is either shrinking or stretching. These transformations are going to be applied to basic functions, and the basic function that we used today in class was the absolute value function. So we moved this kind of a graph up and down and left and right. Now, parent functions are the basic functions that begin all of the transformations that we're going to be doing. So here's a basic parent function, y equals x squared. You should know the graph of this is a parabola, and the points on here are 0, 0, 1, 1, 2, 4, because 2 squared is 4, and 3, 9, because 3 squared is 9. And back negative 1, 1, negative 2, 4, and negative 3, 9, because it's just y equals x squared. Another parent function is called the cubic function. Okay, this is cubic, y equals x cubed. This is called a quadratic function because y equals x squared. This one is y equals the square root of x. So for all of these x values, you take the square root of it. So the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So these are the various points on the square root graph, and this is the absolute value function that we graphed today. These are 4 basic parent functions. Now what we're going to do is we're going to apply the transformations like we did in class on the parabola. So we're going to talk about 2 different kinds of translations, which are the same thing as shifting things left or right or up or down. We're going to do a vertical shift. Vertical means up or down. And a horizontal shift, that means left or right. So first of all, we're going to take this quadratic function, this parabola that we started with here. Here's the parent function, and we're going to shift it up or down. So a vertical shift is when you're going to add a number. A constant is just any number, like 4. A constant, added or subtracted to x squared. So if we want to take the parent function like f of x is equal to x squared, if we want to do f of x plus 4, it's just the same thing as adding 4 to the basic parent function. So the whole thing has been shifted up 4. So instead of starting at 0, 0, this thing starts at 0, 4. And everything has just been moved up 4 from the original parent function. And that's because of this plus 4 at the end. If you want to shift something down, maybe down 6, you're going to add a minus 6 at the end. So x squared minus 6 shifts the whole thing down 6. So this vertex here is at 0, negative 6 instead of 0, 0. And you can always look at these graphs in your graphing calculator too. If you want to put in y equals x squared plus 4 or y equals x squared minus 6, you can see that these would be the resulting graphs. Over on the next page, on page 13, I'm going to show you how to do a horizontal shift. Horizontal shifts happen when you're adding or subtracting a number inside the parentheses. So you can see this x plus 3 here is inside the parentheses, and the parent function y equals x squared. When you have a plus 3, this parent function is shifted to the left 3 units. So instead of the vertex being at 0, 0, the vertex now is at negative 3, 0. So when you have a plus inside the parentheses, it shifts it to the left. Or if you have a minus inside the parentheses, and notice the squared up here because our parent function is x squared, we're shifting 5 to the right. So instead of the vertex being at 0, 0, now it's at 5, 0, and the whole parabola has been shifted over to the right. So inside parentheses means a shift left or right. Outside the well, there's not even any parentheses here, but so outside the entire function means shifting up or down. So you have to keep those 2 things straight. Now I'm going to talk about two different types of reflections that we're going to be covering this year. We're going to be covering reflections in the x-axis. So you can see the original parent function was like this, and if you reflect it in the x-axis, you just fold it down to the bottom, and there it's become reflected in the x-axis. This is the x-axis. So if you want to reflect it in the x-axis, you negate the y values. Well, remember, f of x is the same thing as y, so if you negate the y values, you negate the whole function negative x squared. So a negative on the outside of the function reflects it in the x-axis. If you want to reflect something in the y-axis, you're negating the x values. So look at this. Inside the parentheses, we're negating the x value, and then we're squaring the whole entire thing. And if you think about it, if you reflect a parabola in the y-axis, it actually just folds on top of itself. This part will become this part, and this part will become this part. So the original x squared graph is the same thing as reflected in the y-axis. You just can't see the difference because it's the exact same thing. And then finally, the last transformation that we'll talk about is a dilation. A dilation means something has been shrunk. So if you shrink something, or you stretch something, make it smaller or bigger, you're making a dilation. And we're going to talk about the dilation when you are multiplying the y values by some constant. So the 2 on the outside, this is like 2y. All you're doing is taking the original parent function and multiplying all the y values by 2. So instead of 1, 1, you get 1, 2. Instead of 2, 4, you're going to get 2, 8. Instead of 3, 9, you're going to get 3, 18 because you're doubling all the y values from the original parent function. So that is a dilation. That's a vertical stretch. This is called a vertical stretch because this has been made vertically longer than the original one. So what we're going to do is we're going to take just a random, this is not a parent function, this is just a random function that I made up. And I just connected some lines together, and what we're going to do is we're going to transform this function according to the equations. So I took this random function and I just copied it 5 different times, and we're going to make 5 different transformations according to what it's telling us here. So in this first example here, it's telling us to shift this because this is inside parentheses. This means it's going to be a left or right shift. Left plus means left. Left 1. So what we're going to do is we're going to take the major points. Let's just put some major points on here, and we're going to shift everything to the left 1, all of these points that we've indicated along the way. So the new graph will be shifting this left, shifting this, everything gets shifted to the left by 1. And then if we just want to take our school ID or some straight edge and connect it, you can see what the new graph would be looking like. So that's the transformation of this, left 1. Now this one is not inside parentheses. This is outside parentheses. So this means we're going to shift it up or down. So this goes down 2 because minus means down. So we're going to take the same points that we just looked at, and we're going to move everything down 2. So that goes down 2. I'm just going to do the major points, the vertices, because we can connect these like this. So everything has been moved down 2. This next one, this negative in front of the x means negate the x values. That's what the negative in front of the x means. Negate the x values. of each point. So if we take this point, maybe 1, 1, if we negate the x value, we make it negative 1, 1. Negating the x values means reflecting the y-axis. That's just what it means. So if we take all of these points, we don't even have to take every single one. We can just take the major vertices. And if we want to negate the x-axis, reflect in the y-axis, well, I guess I didn't give you enough room over here. So we're going to go here to 2, 2 goes to negative 2, 2. 4, 2 goes to negative 4, 2. And 6, 4 goes to negative 6, 4, which is about up here, if I gave you enough room. So this has been reflected in the y-axis because the x's are negated. Reflect in the y, negate the x. Down here, the negative in front of the f of x, remember f of x is the same thing as y. This is just like negating the y values. Negative y, negate the y because f of x is y. So that means when you negate the y values, that's the same thing as reflecting in the x-axis. So if you take this point 2, 2 and you negate the y value, you'd get 2, negative 2. So over 2, down 2. This becomes 4, negative 2, and this 6, 4 becomes 6, negative 4. So I'm going to just connect these together. You got your little spaceship going here. This is a reflection in the x-axis. It's been flipped over the x-axis. And then the last example here of the day, this 2 on the outside, 2 times, remember f of x is the same thing as y. This means 2 times the y values, right? 2 times f of x means 2 times y. And so now we can just like write down what these points are. This is 0, 0. This point is 2, 2. This point here is 4, 2. And this point up here is 6, 4. So if we 2 times the y values or double all the y values, 0, 0, if you double this y value, it still stays as 0, 0. But 2, 2, if you double this y value, 2, 2 becomes 2, 4. So 2, 4 would be this point stretched up. 4, 2, double that y value becomes 4, 4. And 6, 4, if you double that y value of 4, it becomes 6, 8. So all the y values are doubled. The x values stay the same. So we're just going to connect this. This has been vertically stretched. You can see it's a taller graph, stretched up. Okay, the x values stay the same. So there's the new graph, and that's it for today.